we have here two salt solutions. One is salty and the other is very salty. And we're asked, when you mix them together, what's the total percentage of salt of the end result? Now, what you want to be careful here with is this is not simply averaging. Okay, we are not averaging. And the reason that's the case is if you have something like this, let's say this is very salty, and you take this, which is pure water, and you mix the two of them together, you can see that you're not just going to cut the salt content by half, right? You're hardly going to change anything because there's hardly any pure water compared to the amount of very salty stuff. So the answer to this is not as simple as just averaging 12% and 26% and getting whatever's in the middle, 14%. What you have to do instead is say it like this. 0.12, that's the salt. And let me highlight what I'm talking about right here. Okay, I'm taking my 0.12 times my 110 liters. Okay, that's the first part of this question. And for that one, that tells me how much salt there is total in that portion. And now here's the other portion. It's a 40-liter solution that's 26% salt. So when I do this one, it's going to be 0.26, that's its percentage, times its volume, that's 40. And to figure out the total salt content, you add them together. Okay, so according to my calculator, this is going to be 0.12 times 110 plus 0.26 times 40. Okay, great. So I get 23.6. Well, that's a little confusing because it's nowhere on our list of choices. What you have to remember, and this is the last piece of this, I'm not just asking for how much salt is in here. I'm saying what's the percent salt of the combined solution. I just found the amount of salt, not the percent salt. So if I'm going to go find the percent salt, I'm going to divide this whole thing by the total volume. In other words, 23.6 divided by what's the total volume? Well, that's 110 plus 40. 110 liters of one, 40 liters of the other. That's going to be 23.6 divided by 150, and that should be my actual salt content, which is 0.157, which is roughly 16%. This is called weight averaging. It's not the same as averaging. You give stronger weight to the things that are in the higher volume.